Okay, now that we've seen the video or the PowerPoint presentation on how coke and iron ore and limestone come together and make hot metal, let's take a little bit closer look at the iron that's used in the process. There's three basic types of iron ore out there. Now, the first one is hematite. Contains about 70% iron and varies in color from black to red. Boy, that's the preferred that you can get. Limatite is a brownish ore similar to hematite but contains water. When the water has been removed by roasting, the ore resembles hematite. Magnetite, rich black ore, contains a higher percentage of iron than any of the other ore, but is not found in any large quantity, so you can't get enough of it to really make it worthwhile. Taconite, well, taconite came from Wawa, north of Sault Ste. Marie. There's a big mine up there, and it's a low-grade ore containing about 25 to 30% iron and must be specially treated before it is suitable for reduction into iron. Well, what they do is they crush the taconite ore and they use magnets to separate it and pull out the iron. From then, it's taken and formed into pellets. And most of the iron making uses pellets. The crushing and the using magnets is passed through magnetic separators, I should say. The iron content is increased to about 65%. The high-grade material is mixed with clay and formed into pellets about 1/2 inch to 3/4 inch diameter and a pelletizer. The pellets at this stage are covered with coal dust and sintered or baked at about 2354 degrees Fahrenheit. The resultant of hard, highly concentrated pellets will remain intact during the transportation and loading into the blast furnace. And the coal, once again, is being converted into coke, is used to supply the heat to reduce the iron ore. The burning coke produces carbon monoxide, which removes oxygen from the iron ore and reduces it to a spongy mass of iron. The limestone is used as a flux in this production of pig iron to remove the impurities from the iron ore. So we talked about the manufacture of the pig iron, and we went through the PowerPoint on that. But we didn't talk a lot about direct iron making. And that's our 15% that we use in Canada. The Algoma Iron and Steel Institute, which represents most of the iron and steel manufacturers, initiated a 5-year development program with the Department of Energy funding to improve the efficiency of iron making. The direct iron making process is based on the melting or the smelting of iron ore with coal and oxygen in a liquid bath. It uses a variety of ores, coals, and fluxes in the manufacturing process and is intended to eliminate the coke and pollution problems associated with coke production. From the reports available, this process, also called bath smelting, has the potential of leading to a continuous, environmentally sound process with lower energy requirements and lower costs. The bath smelting process will use 20% less energy and have an operating costs that are about $10 per ton lower than the coke oven and blast furnaces it may replace. The direct iron making process recovers the high temperature heat from the post-combustion of the process off gas and reuses it in the smelting process. This completely enclosed smelting process is intended to make the steel industry more competitive by reducing its capital and operating costs.